So chapter 9 deals a lot with sequences and series, and most of these are just patterns of numbers. We're going to first take a look at kind of recognizing some different patterns in a set of numbers. In this first example, it says find the pattern in the next two terms, and it looks like we have a sequence here. And so when you're looking at these, we want to recognize a pattern between the individual terms. So to go from the first term to the second term, we want it to be the exact same as going from the second to the third term and from the third term to the fourth term. So it looks like this particular pattern looks like to go from 2 to 5, we add 3. To go from 5 to 8, we add 3. To go from 8 to 11, we also add 3. And so if we repeated this pattern, 11 plus 3 would be 14, and 14 plus 3 would be 17. So the fifth and sixth terms would be 14 and 17 respectively. Looking at the second example, we can try kind of the same technique. We're going to look between the first term and the second term to go from 3 to 6, and from 6 to 12, it looks like we add 3 here, and then it looks like we add 6, and then it looks like we add 12. So that's not consistent, it's not really working for this particular sequence. Instead, there's a better way to represent this pattern through multiplication. And it looks like to go from 3 to 6, we are multiplying by 2. To go from 6 to 12, we're multiplying by 2. And from 12 to 24, we're multiplying by 2. So we kept this pattern going. 24 times 2 is 48. And 48 times 2 is 96. In this third one, we're looking for a similar pattern as well. And hopefully you see right away that we're not adding a consistent number between these terms in this sequence. It looks like we are multiplying instead. So we are multiplying by 4. And that is consistent throughout this pattern. So 64 times 4 is 256. And 256 times 4 is 1024. All right, this fourth one is a little bit harder. When we look at this pattern, there's not a consistent difference between the terms, meaning we're not adding something to get each subsequent term, and we're also not multiplying. But if we look at the common difference between these two terms, it looks like we add 2 here. To go from the second term to the third term, we add 3. To go from the third to the fourth, we add 4. From the fourth to the fifth, we add 5. And you should see that there is a pattern here. It looks like we're adding one more to get each of the next terms. So we're going to add 6, and we get 21. And to get the next term, we add 7, and we're going to get 28. All right, now you try. See if you can do the fifth one down here. All right, this first section of chapter 9 is all about mathematical patterns. And we're going to be talking about sequences today. And as we kind of discussed, it's simply an ordered list of numbers called terms. And there's two ways that we're going to look at describing sequences today. The first one is with an explicit formula. And the second one is with a recursive formula. So first we're going to take a look at explicit formulas. And they ask us to write the first 4 terms in the sequence and then find the 20th term. Notice the notation here. When it says a with a 20 as a subscript, that means a sub 20 or the 20th term. So we're going to take a look at this one first over here. Notice a sub n is equal to 2n. That is the formula that generates each term. Meaning if we want to find the first term, we're to call that first term a sub 1, meaning 1 is now our value for n. And to generate the first term, we would simply use a formula, and we would replace n with 1. So 2 times 1 is 2, so our first term is 2. For our second term, we're going to call that a with a 2 in the subscript, meaning a sub 2. And we'll say that is 2, and we're going to replace that n value with 2 because we were trying to find our second term. So we get 2 times 2 are 4 for our second term. For our third term, we're going to repeat this pattern, and we're going to replace the n with 3. 2 times 3 is 6. That is our third term. And by now you should start to see the pattern developing. For our fourth term, we're going to say this is 2 times 4, or 8. And for our fifth term, we could keep going and plug in n is equal to 5. For our sixth term, we could plug in n is equal to 6, and so on. Now they also asked us to find our 20th term. So the notation, we're going to use 20 as our subscript, and we're going to replace the n value with 20. And 2 times 20 would be 40. That would be our 20th term. All right, let's take a look at the second example. And we're going to repeat the same pattern. Go ahead and put the video on pause and see if you can generate the first, second, third, fourth term, and the 20th for this explicit series. All right, so when we're trying to find the first term, again, we're going to substitute 1 for our n value. So negative 7 times 1 plus 2 would be negative 5. When we find the second term, we're going to plug in n is equal to 2. We wind up getting negative 12. The third term winds up being negative 19. And our fourth term winds up being negative 26. And to find our 20th term, we're going to replace the n value with 20. And we wind up getting negative 140 plus 2, or negative 138. All right, so what you want to take away from this is that an explicit formula always defines the nth term. So we can find the 17th term, we can find the 27th term, or the 150th term. All we have to do is replace the n value in the formula with the number of the term. Once you replace the n value in the formula with the number of the term, simply simplify and you'll find the value of that term. So we've talked a little bit about an explicit formula. Let's talk about the differences for a recursive formula. And it says find the first 5 terms in this sequence down here. So there's a number of differences between a recursive formula and an explicit formula. The first one is that there's 2 parts to it. Notice they gave you the first term right away. And you're going to need this to be able to find any of the other terms in the formula. So they gave us the first term. I'm going to list it again down below. And then we'll try and find the second term. Just like we did previously, we're going to use the notation where to find the second term, n is now 2. And so I'm going to use the formula, and I'm going to replace the n with 2. And what this notation means, and when we simplify this, is to find the second term. If we look at 2 minus 1, 2 minus 1 is 1. So when we are trying to find the second term, it looks like we get a sub 1 plus 3, or simply the first term plus 3. We know from above our first term was 5, so I'm going to say that it is 5 plus 3, or 8. Now let me just repeat this real quick. So to find the second term, we took the first term and we added 3. Okay, to find the second term, we took the first term and we added 3. Let's find the third term. All I'm doing is replacing the n value with 3. And so to find the third term, 3 minus 1 is 2. So we would take the second term and we would add 3. So we take the second term and add 3, or 8 plus 3 is 11. Now, if you look at this, hopefully you see a pattern what's developing here. To find the second term, we took the first term and added 3. To find the third term, we took the second term and added 3. Hopefully you see that to find the fourth term, we would simply take the third term and add 3, meaning 11 plus 3 would be 14. And to find the fifth term, we would take the fourth term and add 3, or 14 plus 3, which is 17. And we found our first 5 terms. Now the one thing you want to recognize is this value up here. When you see this expression, a sub n minus 1, this is always the previous term. And this is how we're going to define recursive formulas. They are always based upon the previous term, meaning we use this to find the second term. We added the first term or the previous term plus 3. To find the third term, we use the previous term and added 3. To find the fourth term, we use the previous term and added 3 again. Let's take a look at a different example of this. See if you can list out the first 5 terms using this recursive sequence. All right, let's take a closer look at this second recursive sequence. So we know the first term is 3, that was given. I'm going to write that again below. And if we want to find the second term, and what this formula is saying right here is we're going to take 2 times the previous term and we're going to add 1 to it. Meaning to find the second term, we're going to take 2 times the first term and add 1 to it. So the first term is 3, so I'm going to say 2 times 3 plus 1, or 7. To find the third term, I'm going to say 2 times the second term plus 1. 2 times 7 plus 1 would be 15. And to find the fourth term, we're going to say 2 times the third term, or 2 times 15 plus 1. 2 times 15 is 30, plus 1 would be 31. And 2 times the fourth term, or 2 times 31, plus 1 would be 63. So we've looked at 2 recursive sequences and we've written out the first 5 terms based upon the sequence. Let's see if we can go the other way. And we're going to look, if we're given the sequence, can we actually write the recursive formula? So very much like the introduction, we're going to take a look at term by term. How did we go from one term to the next? What was the pattern here? And that's what you want to think about, is always what is the pattern? In this case, to go from 2 to 6, it looks like we added 4. To go from 6 to 10, we added 4. And to go from 10 to 14, we also added 4. That's consistent across all of these terms. So we know that that is true for this sequence. So remember, there are two parts to a recursive sequence. The first one is we always have to give a starting point. So the first term is always part of a recursive formula. The first term here was 2. And then we have to write a rule for the nth term. So to find any term, we're going to take the previous and we're going to add 4 to it. So how do we write that? So remember, the expression for the previous term was a sub n minus 1. That means the previous term. So we're going to take that previous term and we're simply going to add 4 to it. And that would be the recursive formula for this sequence. So a recursive formula defines the nth term by using the previous term. And if we're to evaluate any term, whether it's the 10th term or the 20th term, we always have to know the previous term. So we're simply going to plug in the previous term. And then we're going to simplify to find the value. So I just want to make a couple points here. The first one is that this is very different than the explicit formula. Back up when we wanted to find the 20th term here, we simply plugged in 20 for n and we got the explicit. We simply plugged in the 20 for n and we got the 20th term. We did not have to know any other terms and we could have got the 20th. With the recursive formula, to find the 20th term, we would have had to know the 19th term. And to find the 19th term, we probably would have had to know the 18th. To find the 18th, we would have had to know the 17th. So you always have to know the previous term to be able to solve for that term.